9 for the discriminant. Using the discriminant, you can find the number of real solutions with any of these equations. You're just going to be using b squared minus 4 times a times c in order to find out your answer. If you do that and you get a positive number for your answer, you have 2 real solutions. If you get 0 as your answer, you have 1 real solution. If you get a negative, you have 2 imaginary solutions. Another way to do this is finding out how many times the line for this function crosses the x-axis. Same exact thing. So if you get a positive number when you find your b squared minus 4 times a times c, your line crosses the x-axis twice. If you get 0, your line crosses the x-axis once. And if you get a negative number, it never crosses the x-axis. So looking at the first set of examples, we're asked to determine how many solutions each quadratic equation has. So for A, we have x squared minus 4x plus 3 is equal to 0. So our A is 1, our B is negative 4, and our C is 3. So using b squared minus 4 times a times c, we would have negative 4 squared minus 4 times 1 times 3. So the negative 4 squared is 16. The negative 4 times 1 is negative 4 times 3 is negative 12. And 16 minus 12 is 4. This is a positive number, so we have 2 real solutions. For b, we have x squared minus 2x plus 2 is equal to 0. So once again, we can pick out our a, which is 1, our b is negative 2, and our c is positive 2. We're going to use b squared minus 4 times a times c. So this is going to be negative 2 squared minus 4 times 1 times 2. The negative 2 squared is 4. Negative 4 times 1 is negative 4, times 2 is negative 8. So 4 minus 8 is negative 2, and we get 2 imaginary solutions here. For c, we're given x squared plus 4x plus 1 is equal to 0. So for this one, our a is 1, our b is 4, and our c is 1. Plugging this into b squared minus 4 times a times c is going to give us 4 squared minus 4 times 1 times 1. We are going to get minus 4, which is 12. This is a positive number, so we have 2 real solutions. For d, we are given 2x squared minus 6x plus 15 is equal to 0. So we are going to have a as 2, b is negative 6, and c is 15. So b squared is negative 6 squared minus 4 times a, which is 2, times c, which is 15. The negative 6 squared is 36. The negative 4 times 2 times 15. I would do 15 times 2, which is 30, times 4, which is negative 120. When we do this 36 minus 120 is going to give us negative 84. Because this negative is here, we have 2 imaginary solutions. For e, we're given x squared plus 6x plus 9 is equal to 0. So our a is 1, our b is 6, and our c is 9. So we are going to have b squared, which is 6 squared, minus 4 times 1 times c, which is 9. and this is going to give us 36 minus 4 times 1 is negative 4 times 9 is 36. So 36 minus 36 is 0. This is just one real solution. For our next set of examples, it's asking us to solve or use the discriminant to find the number of x-intercepts. So how many times that line crosses or that function crosses the x-axis. So for A, we're given y is equal to x squared plus 5x plus 7. This is the same thing as x squared plus 5x plus 7 is equal to 0. So our A would be 1, our B is 5, and our C is 7. So plugging these in, b squared, so 5 squared, minus 4 times a, which is 1, times c, which is 7. The 5 squared is 25. The negative 4 times 7 is 28, negative 28. So when we subtract these, we get negative 3. Because there's this negative here, it does not cross the x-axis. So it doesn't go through any times. For B, we have x squared plus 2x plus 1. So our A is 1, our B is 2, and our C is 1. So we're going to plug these in. We're going to have 2 squared minus 4 times 1 times 1. The 2 squared is 4, minus 4 times 1 is minus 4. 4 minus 4 is 0. So this crosses the x-axis once. For C, we have y is equal to x squared minus 4x plus 7. So our A is 1, our B is negative 4, and our C is 7. So plugging these in, we're going to have negative 4 squared minus 4 times 1 times 7. This is going to give us 16 minus 28, which is negative 8. So this is none because it is negative. If we look at some extra practice problems, for 1, we have x squared plus 5x plus 4 is equal to 0. Just using our discriminant, our A is 1, our B is negative 5, our C is 4. We would have negative 5 squared minus 4 times 1 times 4. So negative 5 squared is 25. The negative 4 times 1 is negative 4, times 4 is negative 16. The 25 minus 16 gives us 9. Because this is a positive number, we have 2 real solutions. For 2, we have r squared minus 3r plus 9 is equal to 0. So our A is 1, our B is negative 3, and our C is 9. So this is going to be negative 3 squared minus 4 times 1 times 9. The negative 3 squared is 9. Negative 4 times 1 is negative 4 times 9 is negative 36. So 9 minus 36 is negative 27. So this is no real solutions, which means 2 imaginary. For 3, we're given n squared minus 16n plus 64 is equal to 0. So our A is 1, our B is negative 16, and our C is 64. So plugging this in using our discriminant, we have b squared, which is negative 16 squared, minus 4 times 1 times 64. The negative 16 squared gives us 256. minus 4 times 64 gives us 256. So 256 minus 256 is 0, so this is one real solution. For the next extra practice example, we're given 2z squared plus 5z minus 3 is equal to 0. So our a is 2, our b is 5, and our c is negative 3. So this is going to be 5 squared minus 4 times 2 times negative 3. The 5 squared is 25. The 4 times 2 is 8 times negative 3 is a positive 24. The 25 plus 24 gives us 49. This is a positive number, so we have two real solutions. For 5, we have 9y squared minus 12y plus 4 is equal to 0. So our a is 9, our b is negative 12, and our c is 4. So plugging these in using our discriminant, we're going to have negative 12 squared minus 4 times 9 times 4. The negative 12 squared is 144. The negative 4 times 9 gives us negative 36 times 4 is negative 144. So 144 minus 144 is 0. This is one real solution. For 6, we have 3t squared minus 4t plus 3. So our a is 3, our b is 4, our c is 3. So this is going to be 4 squared minus 4 times 3 times 3. The 4 squared is 16. The negative 4 times 3 is negative 12 times 3 is 36. So we have 16 minus 36, which is negative 20. Because this is negative, we have two imaginary solutions. For 7, we're given 4m squared plus 20m plus 25. So our a is 4, our b is 20, and our c is 25. Plugging these in, we're going to have 20 squared minus 4 times 4 times 25. The 20 squared is 400 minus the 4 times 25 is 100 times 4 is also 400. So 400 minus 400 is 0. So this is one real solution. For 8, we have 3a squared minus 2a minus 6 is equal to 0. A is 3, b is negative 2, and c is negative 6. So plugging these in, we're going to have negative 2 squared minus 4 times 3 times negative 6. So the negative 2 squared is 4. Negative 4 times 3 is negative 12 times negative 6 is positive 72. So 4 plus 72 is 76. This is a positive number, so two real solutions. Our last one, we have negative 5b squared plus b plus 1 is equal to 0. So our a is negative 5, our b is 1, and our c is 1. Plugging these in, we're going to have 1 squared minus 4 times negative 5 times 1. The 1 squared is 1. The 4 times 5 is 20 times 1 is a positive 20. Then from here, we're going to get 21. It's a positive number. So we have two real solutions one more time.